Many thanks to PCBWay for sponsoring this video.
Good day everyone, and welcome back to DX Explorer for another video. Today is going to be part 2 on the mini-whip antenna. I'll try to finish this video very fast because it's September 3rd, so that means it's my nephew's birthday and I should go prepare a surprise for him. And hopefully I don't have to film tomorrow because on the 4th it's going to be mine. So I really don't feel like making YouTube videos on my birthday, but if I'm running late with this project I might have to do that too. So anyway, I made a couple of modifications to the circuit board and we'll talk a little bit in just a second about why I made the modifications and what exactly I've changed. And after that we're going to concentrate mostly on building the power splitter part. By the way, I have some really nice enclosures for that one, thanks to my friend Vlad, Yankee Oscar 5 Bravo Delta Lima. I have 2 of them, so it's perfect because I'm going to use one for the Choclovina Scout Center and the other one I'm going to use when I'm going to build the second antenna here for my camper. So we're going to build the power splitter. We'll try to put them together, make a couple of tests, see how it performs, and after that we might have a third video because meanwhile I'm going to try to do a couple of more tests, changing different values in the circuit and see if I can get with what values I can get the best performance out of this antenna. And when I'm going to make the video somewhere towards the end of September about the Choclovina Scouts Camp and the radio room that we're trying to build over there, I'll do a video about the antenna installation over there as well, and I'm also going to tell you the final values of the components that I ended up using, and by that time I should also be ready with a PCB board design so you can build a really nice antenna for yourself. And talking about PCB boards, I cannot go on without saying thank you to my friends at PCBWay for sponsoring this video and always supporting the DX Explorer channel. Please remember they have great PCB prototyping services, they also do PCB assembly, they have CNC services, 3D printing services, SMD stencils and a lot more services available for you. They also have a great module store where you can go pick up some interesting things that might be useful to your projects. I usually like ordering both PCB boards and stuff from the module store, tools or any other things that you might find useful, because they arrive all in one package. If you didn't register for a PCBWay account, please remember in the video description down below you have a link that you can click register for your new account and you'll get a discount in your first order. As I'm always saying, PCBWay is the way. So let's start really quick with the bias T. I like to call it power splitter, but yeah, bias T is the actual correct name. I finished building it. You'll see a schematic on the screen right now. That's the schematic that I based my my build on, and I made a couple of modifications. We're going to talk about those in just a little bit when I'm going to talk about the entire circuit, this one and the mini whip itself. But first let's do a quick test and make sure that it works fine before I'm actually powering up the mini whip and getting any signal out from this one to a receiver or to the nano VNA, so we can do some measurements as well. Alright, so I connected the voltmeter over here. Let's do a quick test. I powered the circuit, the LED is on. I'm going to measure first the power input. I have somewhere around 11.9 volts. The battery is just a little down. I'm going to check the voltage after the diode, 11.25. I'm going to check this point over here by the resistor that's powering up the LED after the switch. So again 11.25. The voltage on the LED is 1.9 volts. The voltage that's supposed to go up the mini whip, it's again 11.25, and the most important part is that we shouldn't have any voltage over here on the RF output that goes to the receiver, and we don't, so it's all good. That means the bias T, it's working. Alright, so before I connect this one to the bias T, I would like to talk a little bit about a couple of changes that I made on the circuit and the reason of those changes. What I didn't put in the video is that last night around 3 a.m. So that's what I do for my birthday. I was trying to do some preliminary tests and see if I can get any results out of this, and I did some measurements with the nano VNA. And also thanks to the comments from you guys that I got on the first part of this video, helped me a lot to understand the circuit. So I was told that it's very important, and I found some original schematic from the original design where it says that it's important that at least these two capacitors, the one connecting the two stages, the transistor stages, and the one on the output, it's very, very important. They are between 470 nanofarads up to 1 microfarad. And I did a test because I told you in the last video that I'm going to start making tests. you know I like changing components and see the result of that. So I did a couple of tests with 100 nanofarads capacitors, and the SWR was quite high. Not extremely high, but also because the impedance was a little bit high, it was close to 75 ohms. And actually I want to power the entire thing using RG58 cable, 50 ohms. So what I did, I replaced these two capacitors with 1 microfarad. These two over here on power line, they seem to be more like filtering capacitors. They don't seem to influence much the SWR. So I guess they're strictly filtering capacitors. I'm using both of them 220 nanofarads. And I think they should be enough. Maybe even 100 nanofarads, it should still be okay over here. Yeah, I guess that's it. You already know from the first video the transistors that I'm using in the circuit, just because I didn't find the original ones, so I tried to use something as close as possible to the original transistors in characteristics. And over here, initially I used a 10 millihenry inductor between the gate of the transistor of the JFET to the pad. I removed that one and I placed a jumper wire right now. So I'm going to use it like this. This is how the original design was. I tried to find out what's the reason of that 10 millihenry inductor, and in some places they were saying that by placing that inductor over there, you will reduce the interferences from above 30 megahertz, mostly from the FM radio stations and so on. I'm going to test it without the inductor, and if I see that I get any interferences, then I will place that 10 microhenry inductor back and use it this way. And yeah, that's it. By the way, here on the bias T, the same thing is valid with this capacitor over here. This is the one that connects the output to the input. This is also very important. Right now I'm using something around 750 nanofarads. It's the best I could find with what I have at this point. But here I'm going to use 1 microfarad as well. There is non-polarized capacitor. Make sure you check the voltage, because I tested one. I put a 1 microfarad over here and it couldn't take the voltage, so it blew up. But it wasn't here actually, I think it was here. Anyway, these two on the voltage part, on the DC rail, I'm using 100 nanofarads capacitors, and it seems that they don't seem to influence the SWR reading either. So yeah, as I was saying, let's put them together really quick. Let's connect them and do a quick nano VNA test here inside. We'll do a quick receive test. I'm going to try to transmit with the PTTCO2 into a dummy load and see if we can receive it in here, listening into the TrueSDX. And after that I'll have to go outside and put the miniwhip outside, install it, do the entire installation, run the coax cable inside, and do a final test to see if it actually works and we can receive something. Oh, one more thing, just because I tested this and I don't want to test it on camera to waste your time, I actually tested the current draw of the entire circuit, both of them together. It only draws 50 milliamps, so it should be fine, according to the original schematic, where it was saying that it will draw around 55 milliamps. So I guess I'm somewhere close to the original design, which is a good thing. Alright, so I finished placing the bias T into the enclosure. So here I have the power and the output that goes to the mini whip. Over here we have the output that goes to the receiver and the switch and the LED. I'm going to power it. I already checked this, everything works fine. So right now we can just take it away, bring in the mini whip antenna. I'm going to connect the BNC that goes to the mini whip to the bias T, and this one gets power as well. Now let's do some voltage checks really quick, and after that we can carry on with the test. Alright, so let's check the voltages over here. On the power rail, about 10.4 volts. Here on the base of the transistors, I get 6.8. Let me focus on the multimeter. Over here on the emitter, I'm getting almost 6 volts. Let's check here. 10.4 on the gate, 4.3, and on the source 4.3. Not sure if the voltages are correct, but it should be okay since the power draw was pretty much as it was in the original design. So now we can run some quick tests on the Nano VNA and see the results. Okay, so here we are on the Nano VNA. Sorry for the reflections in the screen again. I did not have the time to switch lenses and use the polarizing filter. So somewhere around 30 megahertz, my SWR is somewhere close to 1.4. If I go lower in frequency, somewhere around 21 megahertz, I'm getting 1.2. And then all the way down to 5 megahertz, somewhere around 1.4. Around 3 megahertz I get 1.5 SWR, and then it goes crazy under 3 megahertz all the way to 3.2 to 1 on 10 kilohertz. So probably it might be because of the transistors that I'm using, that it doesn't have such a good response on the very low frequencies. But considering that I can cover the HF band, I'm pretty happy. Now let's remember that my antenna, it's actually on the table. So probably once I put it outside, maybe the SWR might change, but I doubt that. It shouldn't affect with anything. Let's put it somewhere on the 40 meters band, for example. Let's go 7.2 megahertz. I'm gonna raise the antenna up and see if the SWR will change, but it doesn't. It stays to 1.4 to 1. We'll see when I get outside. When I keep it away from everything, if anything will change, I'll do some measurements again, just for myself to see if I see any changes. But that's it. This is the result so far. Now let's do some tests and see if I can actually receive something. So I apologize for the bad lighting, but look what happens if I turn on the LED light. So it picks up the LED light. Now I'm going to connect my PTTCO2 CW transceiver, which is somewhere around 7.2 megahertz, and I'm going to start transmitting to see if it will pick it up. And it does. I'm quite far with the dummy load from the antenna. Now I'm going to bring it closer. You can hear the oscillator. Let's transmit again. So it works. It picks up this one. Now I'm curious, once I take it outside, if it will pick up anything on the outside. We'll do a quick test over there. So here we are outside. I made a quick setup over here with the antenna installed temporarily, just because I realized that I don't have coaxial cable to actually do a proper installation. I have a couple of meters of coax that I'm using for the vertical dipole for the 2 meters and 70 centimeters band, and I have to take that antenna down and take it up to the Choclovina Scout Center, but I decided not to cut that cable because it's connected straight to the antenna and it's already set up over there. I just have to install it and that's it, so I don't want to mess up with that. I have about 5 meters of cable right now, maybe 4 or 5 meters. I installed the antenna here up on this pole. It's not higher than 3 meters, so the results shouldn't be so great. But what matters the most to me is if it can receive something. So let's do a test. I'll show you where exactly I put the antenna right now. So here on the ground I made my temporary setup for the radio, and the cable goes up on this temporary fence, and I have this pole and that's the mini whip over there installed temporarily with a little hook that is holding it up. It's probably about 3 meters high, it's not higher than that. So what I'll do now, I will have to cut my microphone and I'll connect the TrueSDX to the wireless microphone, so you get to hear actually what I'm hearing in the TrueSDX and if we can actually receive something. Again, it's very important. I don't care much about how sensitive it is at this point, because I'm interested to see if the antenna works and if I can actually receive something, because I have to take in consideration that the antenna is not properly installed. There's no grounding at all, and apparently it's very important on how you ground this antenna. I'm still learning about that part because there's a lot of confusing information online. Some people are saying it's good in one way, it's bad in the other way. Other people are saying exactly the opposite. So I'm still trying to understand what's the best part to ground this antenna and where, in what point. So and of course it's very important to put it as high as possible. With my antenna up at 3 meters, I don't think I can get very good results. Yeah. So anyway, let's connect it really quick and see if we can actually receive something.
Предыдущий старший Владимир Калуга, а край на Калуге Владимир Кирсов. Россиянскую станицу Сирии прекрасно. Ну, в красном секторе там не будет через рейс, а тут...
Well, I guess this is the test for the antenna. From what I read into the article of, from the radio magazine that my friend Andrei YO6TJJ wrote about the mini whip antenna, is that the sensitivity of the antenna is directly proportional with the height of the antenna. So the higher the antenna and far away from everything else as possible, the better the results and the better the sensitivity of the antenna. Also, I was checking with my friend Hendrik about the size of the pad of the antenna. The one that I'm using right now, I kept it to the original dimensions that it was written in the very original article about the antenna, which is 3 centimeters by 4.5 centimeters. Hendrik told me that his pad it's actually 4.5 or 5 centimeters by 10, so it's a little bit bigger. Not sure how much that will influence the antenna. Some people say that the smaller the pad the better, because it will pick up less interferences and so on. Others are saying that if the pad is a little bit bigger, the antenna becomes a little bit more sensitive, but I'm afraid not to make it too sensitive. So it will pick up a bunch of garbage that's not supposed to be there. So I'm still trying to decide about the size of the pad, but most probably I'm going to stick to the original design, 3 centimeters by 4.5. So yeah, at least it works. I know that even with the bad installation I do receive something, not much, as you could tell. I've been wandering around on the 20 meters band. The propagation is not the best right now either, so it's not really a good day to make this antenna test. But my cats just came back with a couple of mice. They keep bringing me presents. So yeah, it's not the best day to make tests. I've been testing the reception on the nth half wave earlier as well, and I couldn't hear much either on that one. So my idea is that at the end, once I get to Choclovina, by that time, hopefully thanks to you and your wonderful comments, I might understand exactly and a little bit better the grounding part of the antenna and how is the best to install it. And this way, by the time I get there, I have all the knowledge about this antenna, and I will get some good results once I install it over there. I'll have to buy some coax cable, and yeah, hopefully over there we get some really nice results. So before I end this video, I wanted to say thank you to Dash Ventures. Not sure who's the man behind Dash Ventures and what's the name of the man, but he's 88 years old, and he sent me a good PayPal donation that it came right on time to order a couple of more components for finishing this antenna. And he built his first crystal set 80 years ago, so he was only 8 at that time. And I love these wonderful stories and these wonderful comments that I get from people in email sometimes with like little stories on how they started in this hobby. And yeah, I think it's wonderful, and I'm very thankful for all the people watching the video. So yeah, I'd like to say thank you one more time to everyone and each of one of you for watching the videos, because that's the only reason why I'm still here on YouTube making videos, because I could really enjoy the hobby on my own without filming anything and without posting stuff on the blog, and probably it would be a lot easier for me. But it's nice to also share what I'm doing, and thanks to your comments I'm learning a lot of new things. When I do a mistake or I do something bad and I can improve something, you also let me know, and that helps me very, very much. So yeah, thank you so much. One more thing, once I finish with this antenna, and I'm still going to make tests until I live in Choclovina. I'm going to try to replace all the capacitors as it was in the original schematic with 560 nanofarads. I will do my best to also find transistors and test different sort of transistors to see which one will give me the best results, because J310 I cannot find it anywhere here in Romania, so I need to find a replacement that it offers results as close as possible to that one, and it's still available on the market. Not like you can find some bad copies, bad replicas, or you can find some limited stock, because and is valid the same for the NPN transistor, because you have to remember that once I designed the PCB board and I posted on the PCB Way project page, PCBWay also offers the option for you to buy the assembled version, so the version that has all the components on it, and extra with that assembled version you can also buy the simple PCB board that they're selling. But sorry, I had to stop, there was a truck passing by. When you order the assembled version from PCBWay, I'm placing there the bill of materials file with all the components, the value and what components are used for that particular project, and PCBWay has to order those components in order to be able to assemble that particular project. So it's very important that these components that I'm using in each project that I post over there on the project files, on the projects page, they can find those components online, so they can order them in order to finish your assembled project that you're ordering. So yeah, that's the reason that I'm struggling to find really good transistors, and I'm doing the best I can with the limited knowledge that I have to design something that actually works, and when you order something from them, you're actually happy with the results. So yeah, anyway, that's it for today. I hope the video didn't get too long, but yeah, I'll get back probably sometime at the end of September. Once I come back from Cioclovina, I will go there, I will film the entire antenna installation, and hopefully over there we get better results. But in the meantime, if you have some good knowledge about how to properly ground this antenna and how to get the best results out of it, please let me know down in the comments, because it means a lot to me and it makes my life a lot easier. So thanks so much for watching. Sorry for the long chit chat, but you know, I'm trying to explain things the best I can. So yeah, I guess I'll see you in the next video. Until then, 73 from Yankee Oscar 6 Delta X-Ray Echo.